Perfect. Good morning. I'm Mehdi Asnashari, work for Crossbar, and now we have a new subsidiary of Crossbar called Cramium Lab that works on crypto controllers. Crossbar itself has been around for 12 years, mostly working on resistive memories, and Cramium Lab is subsidiary that uses some of that crossbar technology, but mostly is on security and crypto, especially in area of the crypto and cryptocurrencies, where it has a lot more crypto engine demands. Okay, so it's a brand new division. It's been about 9 months in you can find more information in the link. Sorry, it's in the link here. Okay, so the question we have today is is about the bootloader, because we're making chips, we're not making systems at this point. And the question is, what should the bootloader do for this community? Should it be just very minimum code that only opens up the communication port and OEM will take care of everything else? Or should it do all the crypto engines and at the API level, and let OEM do more of the IOs and displays and customizations? So this is the question for this community. Or should it be something in between, And then the question is, how much OEM trust manufacturer? Bunny mentioned that is almost no trust, but is or what can we do to improve that perception? Okay. So here's a block diagram of a typical crypto processor. This is not necessarily what we're working on, but this is it's a crypto processor. It has a lot of accelerators, all the primitives. It has large megabytes of NVM, so all the codes and everything will be resident inside. And beside code, it would be all the configurations, keys, secrets, and bootloaders and user code and so forth. And you will only need and maybe external SD card for updates. Other than that, all the codes would be running here. And if the code is not big enough with the whole code, then some of these NVM can also be used for updates. So we don't need to use SD card. We can just go directly into the empty space, unused space here. And then once it's validated, we can load it into the user space. It has a microcontroller. Of course, it has the IO port. So this is pretty typical. And this is the crypto functions that use these primitives to implement the actual functions itself. So it's like some of them are still somewhat primitive, like SHA and AES that are still here, but then you have the elliptic curves and things like that will use many of these primitives. But when you use these crypto functions, these atomic operations or the accelerators are designed so that the information remains within the crypto engines for the next atomic operation. So it's not, you can use those atomic operations within the crypto accelerators that none of the intermediate values will leave the crypto engines. You only give the inputs, and at the end you get the outputs. So the CPU, or if you choose to, if you code it like that, so there won't be any leaks of the intermediate values. Okay. So if we look at the minimalistic view of what the firmware or looks like when we ship the product would be just some um, a very small bootloader. So this MVM here is expanded in on the right side, and all the chip bootloader does is opens up the ports and let the OEM download OEM bootloaders. So it doesn't do really anything. And also we fill in the manufacturer areas with trims and for just calibration data and so on. And maybe we just move the life cycle of the device from chip to OEM. So we'll fill in this area here, very small amounts of code, and and this code is just for loading the OEM bootloader. Once the OEM bootloader is loaded, then you don't even use that. So there is absolutely no trust in software that is loaded into this platform. And if you look at the life cycle progression, is that so we fill in this during the test of the controller, and then we ship it to OEM. OEM will put their move the life cycle from chip to OEM. It will maybe use some of the slots, put secrets and keys and so on, and it will configure how those slots are going to be used. It loads the OEM bootloader. If chip bootloader is no longer would be used, the test vector, the reset vector will move from here to here. So pretty much this part of the memory can be reused, because the OEM still can do everything that the chip bootloader does and a lot more. Okay, and the way we're thinking right now is only one way life cycle progression. So that is just going forward, and there's once you go from chip to OEM, you cannot go back to chip for security reasons. But then that's one of the questions I have at the end, is that do we need to go back to some test mode or something where we can during the postmortem, if there's some parts are coming back, how do we know what went wrong? Do we need just we don't have full access in the user mode to the chip, so is without being backdoor. So you don't want to have a backdoor there. So that's sort of the question we also have in this. The other option is to have a full feature software where everything here is loaded into the chip bootloader. So all the crypto functions are loaded during manufacturing. So we have of course the trims and everything, but we still move the life cycle to OEM, but now we put a lot of information into the chip, and we might use some keys and passwords space and some of the configurations of those slots. So in this case, it not only it opens up the ports, it also run post, like power on self-test. It has all the crypto functions, and once it gets loaded again, you can only execute from it. It cannot be, because it might have some keys and things like that. So it can only be executed. It cannot be read or written. And there would be potentially a small, these are again all configurable, the sizes of these spaces, but there could be potential space for OEM bootloader where they can supplement what we have if they need additional crypto functions that are not part of our standard offerings, or they want to improve some of these functions. They could do that within this area here, and then once they load that, then they lock it up again. So so it's executable only. And then you always have this user space where you have all your customizations, and you can upgrade this at the during the at post production. So this is the standard user code upgradable at here. It's signed and it's upgraded. Okay, so so the life cycle would go from OEM to user mode, where this was the OEM life cycle. This is the way we ship the parts, but then the user will fill in the rest of they will add in the seeds and pins and things like that, and of course the user code gets loaded also. So once you go to this life cycle, then this is the finished product. Okay. And again, the questions here is that what can we do, or to improve the supply, to improve this experience, or maybe not experience, but your trust in the chip, where the whole idea is reduce the time to market. So what should we, if we already have all the codes, how can we, what other tools can we send to increase your trust in the code and hardware that we're shipping? And then do we need to have some features like supply chain authentication of the chip itself? I know we do the supply chain authentication of the product, but should it be also done at the chip level? And should we support reverse life cycle progression? If we can destroy all the secrets, is that something? But then how do you trust that we do destroy the secrets and so on? So this is a real, question: is what should we consider shipping the product as, and what features should we have that this should be concentrated?
Okay, thank you.